Well, in that period between the mid-50s and 1970 already is 15 years, I don't think, the paper was certainly not unknown, but it was considered, I remember even as a student hearing, it was considered somewhat mysterious. When did you become aware that these theories were emerging as the theories of what's now called the Standard Model? When did it become clear, and did you have some faith that this eventually might occur?
It was a gradual process. If you ask, when is it generally accepted that this idea is correct, after you add the symmetry breaking idea to it, that really was in 1972. So all between 54 to the 70s, what happened was, for example, our paper was published in 54. Nobody ever invited me to give a talk in the next 10 years about the subject. I did give a talk at Harvard, but what happened was Harvard was looking for a young professor. So they were interviewing various people, so I was one of them. But they didn't assign a topic for me to talk. They just say, we want you to come and give a seminar. You name the title. So we talked about this. I remember that I talked to a large audience, and at the end of that, there was not a single question asked. In the audience, there was Ramsey, there was Schwinger, there were many people from MIT. I think the general view was that the idea is very beautiful, but it has nothing to do with physics.
What year, do you recall the year?
That talk was in 54.
Oh, it was, right then.
Yes. Now, after that, as I said, nobody ever invited me or Bob to give a talk on the subject. But then about 7 or 8 years later, I think in late 50s, Murray Gell-Mann somehow became interested, and he generalized what we did to a bigger symmetry. But of course, that paper also did not immediately materialize as something agreeing with experiment. The Russians got onto it also around 1960, because I was sent a Russian book, which is a collection of papers about related to the subject, which shows that by the early 1960s, there were scattered people in the Soviet Union who found the idea interesting. So there were several papers, in fact, there were many papers written, but some of them were collected in this little book. The crucial development which made gauge theory important was first because of a paper in 1967 by Steve Weinberg. Steve Weinberg said that if you marry the gauge idea with symmetry breaking in a specific context, the problem with symmetry breaking is that it's not unique. Gauge theory is quite unique. Symmetry breaking is not unique. He said that he proposed one particular version of symmetry breaking and said that this might work. In addition, he predicted, predicted is too strong a word. He sort of said, perhaps the whole theory is renormalizable. Renormalization is an important requirement for any theory of this type. And he did not prove that it's renormalizable. But he sort of guessed that it might be renormalizable. That renormalizability was proven in 1971 or 72 by a young graduate student in Netherlands. And also at the same time, experiments began to show that this combination of gauge theory with symmetry breaking produced some experiments which were found to be correct. So starting about in the early 1970s, two things. One, these experiments. The other is the renormalizability pushed the idea forward. And then it became sort of a idea which dominated the field. And amazingly, since that time, with thousands of complicated and beautiful experiments, more or less the original idea of Weinberg's combination, Weinberg's choice of how to do symmetry breaking seems to agree with all experiments. What's the lesson that one should learn from this? Is that I would say, A, one should explore beautiful ideas. B, one should not be deterred if one beautiful idea does not solve all problems. C, I think editors should not be too harsh on people who write exploratory ideas.